My subject was physical activity monitoring patches. So the study I chose was the effect of wearable sensor dynamics on physical activity estimates. It was a comparison between spinal cord injury individuals and those that were deemed healthy. The study was run by the authors listed below. It was published in 2016 by the Institute of Electrical and Electronic Engineers. Um, this slide essentially states that there's been a rise in commercial activity monitors being used in the clinical and rehab setting that's supported in 2012 by Remortal HV. And there is also a need to validate these commercial activity monitors, and that's supported by McGarity AM in 2014. The purpose of this study was to study the influence of activity monitor placement on the accuracy of the metrics estimated by commercial activity monitors. The second goal was to investigate the accuracy of the proprietary algorithms in estimating physical activity metrics for populations with disability. So the method and why this study correlates to our assignment was the utilization of the comparison of an actigraph, which was a wearable, the Metri IH1, which is the patch, and it was all compared against the Cosmed K4B2 system. So what are these? The actigraph is worn on the wrist, on the ankle, or on the hip, and it records continuous physical activity and also sleep-wake information. This is the patch, Metri IH1. It's a disposable device. Detects user skin temp and physical activity. On their website, it says it's designed for patients with diseases or those taking part in weight loss programs, but I'm sure it could be used in other settings as well. That information is based on Ventrico.com. The Cosmed K4B2, which is referred to as the gold standard, it's the first portable breath-by-breath gas exchange analysis system. It's used and mentioned in over 600 publications. The study's hypothesis was that device location, the population studied, and choice of proprietary algorithm and type of technology would significantly impact the accuracy of the predicted physical activity metrics. So the method of this study was 18 subjects were used, 10 were healthy, and 8 were deemed individuals with spinal cord injuries. The exclusion criteria, no serious cardiac conditions, no neurological degenerative pathologies, and they all had to be able to sit unsupported and were able to walk, at least with an assisted device. So the structured activity test, there was 3 tests within this study. The first was a sedentary activity level, and this is where they measured the participants just lying down on a treatment table for 2 minutes. The second test was what they titled moderate activity level, which was walking 50 steps. The third test, titled high activity level, was a 6-minute walking test. Sufficient rest and recovery was provided between each activity. So the data collection process was all 3 devices were worn by the participant during the entire protocol. The investigation compared step count and energy expenditure. The step count and energy expenditure data was extracted from all the devices using its proprietary software provided by the respective activity monitor manufacturer. The steps taken during the low activity level were manually counted using a smartphone counter. Stat analysis, they used SPSS 17.0 with a significance level of 0.05. The outcome estimates were plus minus 95% confidence index. Like we said before, the actigraphs and Metria 1 were compared with the Cosmed K4B2, which was utilizes the gold standard for validation of the metrics. So in the results for the sedentary activity, the ActiLife algorithm underestimated energy expenditure when compared to the gold standard, the COSMED K4B2. There was no significant difference observed between the energy expenditure in the patch, the Metria IH1 and the COSMED in healthy and those with disability. Those can be seen in the table to the right. Results for the low intensity was that both the Actigraph and the Metria accurately predicted the step count in the healthy control group. However, those in the disabled group, only the Actigraph position at the ankle could accurately estimate the number of steps. The Metria underestimated the step counts in the spinal cord injury group. Energy expenditure also in this low intensity at the waist and ankle, they were significantly different. So with the Actigraph worn at the waist, it was significantly less than the gold standard in the disabled group. Results in the high intensity was there was no significant differences in the predicted energy expenditure in the 6-minute walk test when compared to the COSMED. So discussion, the overall results. The patch was the most accurate in evaluating energy expenditure during the sedentary and low intensity activities when compared to the Actigraph. The step counts for individuals with disability was accurate when the Actigraph was placed on the ankle. The postulated hypothesis was found to be accurate, meaning that the type of technology used will significantly impact the accuracy of the predicted physical activity metrics. So furthermore in the discussion, a theory on why the stickable or patch outperformed the wearable monitor was that the Metria IH1 patch had an algorithm that integrated more information than the Actigraph. The patch has an accelerometer, measures skin conduction, body temperature, basal metabolic rate information, behavioral aspects like smoking to estimate the energy expenditure. These were all theorized to increase its validity in measuring the physical activity within the study's participants, whereas the Actigraph mainly relied on the accelerometer data. And a second reason was that the adhesion from the patch directly to the skin could have minimized error, whereas the Actigraph has some play in it. So in conclusion, there's some implications for health practitioners moving forward when we want to monitor physical activity. There's some things to consider. We need to be fully aware of the customized algorithms that the technology that we want to utilize that will play a significant role in the accuracy of our study's parameters. Also consider where this device is worn and the technology that it utilizes. And this is all based on whatever physical activity, intensity, and duration that we tend to use. The physical activity monitoring patch seems to be a promising field. It just lacks large subject studies. I found another study that had 52 subjects. I could only pull up an abstract, and in the abstract it said that they found validity in measuring with the IH1 patch as well. This study's limitations were the small sample size of only 18 participants, and also I would like to see a study where there would be more intense activity and really test the patch's adhesion to the participant, because right now it seems pretty easy to use, but during high intensity activity where sweat levels increase, I'd like to see the durability of the patch. And so further studies would be a larger sample size and more differentiated type of exercise. Thank you for listening.